Hi, let's take a look at how we can use the leading coefficient test to determine the end behavior of graphs of polynomial functions. So we first need to define a few terms. What is the degree of a polynomial function? Well, the degree of a polynomial function is the highest power on the variable terms. So for instance, in a quadratic, the degree is 2. In a cubic function, the degree is 3. A linear, the degree is 1. So it's just the highest power on the variable. What is a leading coefficient? The leading coefficient is a coefficient on the term with the highest power. And it turns out that the end behavior of a polynomial function depends on both the degree and the leading coefficient. Hence the reason this is called the leading coefficient test. If you can remember just two simple things, if you can remember what the graph of x squared and the graph of x cubed look like, you're going to have this down with no problem. So let me show you. If we have an odd degree with a positive leading coefficient, you need to think of x cubed, okay, which looks something like this. So it turns out that a polynomial function that has an odd degree and a positive leading coefficient will always look like the graph of x cubed at the ends. So that means to the left it's going to be down, and then it's going to end going up to the right. Now what about an odd degree with a negative leading coefficient? Well, that's going to be the reflection of the x cubed. So that's going to be the one that looks like this. Okay, now all in the middle is going to be something else going on, and I'll show you that in another video, but right now we're just looking at the leading coefficient to determine what the end of the graph looks like. So for odd degree with a negative leading coefficient, it's going to be up to the left and going down to the right. Okay, let me draw a line here so we don't get those confused. Now an even degree with a positive leading coefficient, for this one, if you can think of the graph of what, x squared. So to the left it's going up, and then it's going up on the right. Remember, so even degree is doing equal things on opposite sides. Odd degree is going to do opposite things on opposite sides. And then lastly, what about an even degree with a negative leading coefficient? Well, think of the reflection, right, like that. So that's the parabola that's going down, so that means that the end behavior is going to be going down in both the left and the right direction. So if you, again, think of x squared and x cubed, then you'll have all four cases that you need. Well, let's do some examples now. So what we have here is to determine the end behavior of each function. We're going to do that by looking at the degree and the leading coefficient, and then we're going to match it with which one of these possible graphs could be the graph of that particular function. So looking at the first one, y1 is negative 5x cubed plus x squared plus 3x minus 4. The only thing we need to look at is this negative 5x cubed. Now, the reason behind that is because as x gets larger and larger and larger, this highest power takes over and really determines the outcome of that function. So as x gets larger and larger and larger, the values are really close to what negative 5x cubed would be. So that is the term that's going to determine the shape of the graph as it gets large. As x gets large, or x gets really, really small. In other words, as we go to positive infinity and negative infinity. So we have to look at, well, what is the sign of the coefficient? What about the power? So this one is an odd degree, right, because of the 3. And the coefficient there is negative. So if you can remember, x cubed was a positive going up, right? From the left was going down, right was ending up, but now we have to take the reflection of that. So the end behavior should be up at the left side and down at the right. Now we'll match them to the graph in just a minute. The next one is 7x to the 6th minus x to the 5th plus 8x squared minus 8x plus 3. So in this particular one, our leading coefficient is 7, which is positive. And what about our degree? It is 6, which is even. So think about the graph of x squared, and that's going to tell you what the shape at the end will look like, where it's going up to the left and going up to the right. The next one is negative 4x to the fourth minus 13x cubed minus 8x squared minus 1. So our leading term there has a negative coefficient, and it is an even degreed function. So that's going to be that reflection of the x squared graph. So that's going to be going down from the left and to the right. Now we finally end with 3x to the fifth minus x squared minus 8x plus 5. So this term has an odd degree and is a positive coefficient, so that's going to be like the shape of x cubed at the ends. Now understand, the highest powered term does not have to be the first term of the polynomial. Just be sure that you kind of survey the polynomial, make sure that you're looking at the one with the highest degree. Okay, so let's match these. We'll look at the graphs and kind of go backwards now. So we have this one where it's going up on each ends, to the left and to the right, and so that is going to be our even degreed with a positive leading coefficient. The second one is going down to the left and up at the right, and that's going to be our odd degree with a positive leading coefficient. Then we have a function whose graph is going up to the left, down to the right, so we know that's odd, and that is the one with a negative leading coefficient. And finally, we have a polynomial whose graph is going down in both the left and the right, so that's going to be an even degree with a negative leading coefficient. Okay? So that's how you can use the leading coefficient test to determine the end behavior of a function.